All right, welcome to today's webinar. This is part of the Cold Climate Fruit webinar series, which is co-hosted by University of Minnesota Extension and University of Wisconsin-Madison Division of Extension. My name's Annie Clodd. I'm an extension educator for fruit production at University of Minnesota, and my colleagues from Wisconsin are on the line here today too. Today's topic is sprayer tank mixing, and our speaker today is Jason Deveau from OMAFRA, which stands for Ontario Ministry of Agriculture, Food, and Rural Affairs. And his position title is Application Technology Specialist, but he also goes by the Spray Guy. And so you can find him on Twitter at spray_guy. And so he has a wealth of knowledge about sprayers, calibration, application, all kinds of things. And so he's going to be focusing today on sprayer tank mixing, but think of your other questions, anything sprayers that you'd like to pick his brain about after the presentation as well. So we'll have plenty of time for Q&A today. Speaking of Q&A, if you want to ask questions, I think everybody's pretty used to this by now, but just as a reminder, if you hover over the bottom of your screen, or maybe it's at the top of your screen, but usually the bottom, you'll see a little icon that says chat. You can type your questions or comments in there, or you can type them in the other icon that says Q&A with a couple little speech bubbles. Either way will work. All right, so I'm going to turn it over to Jason.
Thank you very much. I'm going to steal away the screen share. And then I'm going to make full screen. And Annie, if you could tell me if you've got the right thing on your screen, we'll get rolling.
I do, looks great.
Hey, this beats what I did this morning where I was 3 or 4 minutes into my presentation when somebody cautiously said, should we be seeing your slides? So very professional. You'd think after doing 2 or 3 of these a week, some of them in a day, I would get used to the keystrokes so that you could see everything, but hey, I guess not. So thank you for having me. I like this talk. I was confessing to the hosts that this is a talk that I was afraid of for years in my position as application technology specialist, because, you know, it's chemistry, right? It's physical chemistry, and it's also biology when you think about the phycology or how the chemistry affects the plant. And to be frank, that's not me. My degree was in biochemistry and plant physiology, I admit, but boy, that's a long way from physical chemistry. So who could just sit down and confidently tell you what to put in your tank and what not to put in your tank? But over the years, I've met a lot of very clever people who were generous with their knowledge and helped me to build this presentation and build my own understanding of what's right and what's wrong. So I'm going to give full credit where credit's due. A lot of this most recent iteration was co-developed with Mike Cobra, who is our provincial field crop weed specialist. And he fell into this innocently and stupidly by asking me one day, how come all my field sprayers are getting filled with Jello when they use fertilizer as a carrier? So I put a gentle arm around him and said, welcome to a terrible, bigger world. And he and I developed a lot of presentations. And here's a gratuitous shot of Mike's bum as we did one of 50 presentations a couple years ago. It says 40 times, but boy, they just kept going. And what we wanted to do, and this happens to be for field croppers, but there's a lot of crossover for horticultural crops, particularly air blast. What we wanted to do was actually demonstrate physical incompatibilities and show people the impact of certain variables. So we came up with a Bill Nye the Science Guy approach to it. We just wired everything. We had GoPros and cameras and jars of chemistry. And thank goodness nobody asked about fume hoods since we were using a few ounces of actual chemistry, but we felt it was safe. We wore gloves and it wasn't warranted. Anyway, forget I said that. Glad we're recording this. But we did get to demonstrate in real time how physical incompatibilities can occur. And people in the audience saw things turn to gel and emulsifiable concentrates just seize up and fall out of suspension. It was powerful. What was really interesting to me and what keeps me interested in this role is that at the end of the day, somebody would always hang behind and tell me that this had happened to them. This could be a grower, or this could be an agrochemical rep or a salesperson. We had chemists from some of the agrochemical companies, the registrants themselves, tell us that they see this. And we ended up working with a large group of Syngenta scientists. We have a local research lab called Honeywood, and they have the coolest job. They try to break chemistry. They take chemistry sold by Syngenta all over the world, and they look to see if the formulations work in different regions in Canada. For example, in the cold of Alberta, you may have chemistry sitting in unheated sheds for a lot longer than you would in Southern Ontario, where I am. And the chemistry responds differently. So they would try to break them, and we worked with them looking at tank mix order and a number of other things. I learned a lot. Just another example of why agriculture is so cool, that everybody's willing to share information across different disciplines. So let's start with a pretty picture. This was by Peter Smith at the University of Guelph, and he won a photography award for this. This is what happens when you add Prowl, which is a herbicide, into glyphosate, another herbicide, and it's gorgeous. I think it's gorgeous. But it leads us into what tank mixing is. Tank mixing is when you put more than one formulated product in your solution tank at the same time, just so we're all clear. Now, unlabeled tank mixes, the rules for that will change depending if you're in the United States or if you're in Canada. There are different federal policies, there are different state or provincial policies, and even regional policies. But in Canada, where I am, users of commercial class pest control products for crop protection or vegetation management, they are allowed to tank mix if they obey the following things. Each tank mix partner has to be registered for use on that crop. You can't chuck something in that seems like a good idea if our pest management regulatory agency hasn't approved it for use on that crop. The timing has to make sense. You know, it's not like you can ignore IPM and decide to put something on that'll be of use down the road. No, you know, the problems or the opportunity for certain products, they have to align in time. It's got to make sense. Each partner's got to be used according to the product label. If something wants to be really, really dilute when it goes on and something else wants to be really, really concentrated, they may not make good bedfellows. You can't put 6 things on a crop if one of the labels specifically says, don't mix me with one of these other tank mix partners. That's a no-no. And adjuvants get a little tricky. And adjuvants are one of the wild cards in tank mixing. It seems everybody has a potion that's meant to do something. It could change how a droplet is deposited. It could increase spread over a target. It could make it stickier so it doesn't wash off hard to wet targets. It could be for drift. It could be for any number of things. It could affect the carrier water. Maybe you need to change your pH. Maybe your turbidity is too high and you know a product will be deactivated. Adjuvants are just kind of everything that isn't the pesticide. And in Canada, our adjuvants have to be registered, but in the US, I believe, they don't. Like if you choose to put it in your tank, it's kind of caveat emptor, buyer beware. It's your bad. So we'll get into that. But at least in Canada, if you want to use an adjuvant, one of the labels has to call for it before you're allowed to put it in. So why would you do this? Why would you risk making this witch's brew? Efficiency. Boy, doesn't it save time to pass over the field or through the orchard or through the vineyard once instead of half a dozen times. And there are a lot of good reasons for that. Not only do you save time and money, but you avoid things like crop damage. For people who spray a sensitive crop, we'll say high bush blueberry. A lot of guys don't like to spray multiple times because physically bumping into the plants destroys the berries. They're super sensitive. So they don't like to pass down the alleys any more often than they want to. Another reason is compaction. Certainly early spring, if it's a wet spring, every time you drive a sprayer through there, you've got ruts you're going to have to deal with for the whole season unless you fill them in. It's not good for soil health. It's not good for roots. It's certainly not good bumping and banging down the alleys. So lots of good reasons there. Resistance management is another great reason. And we hear about this with weed control all the time. Multiple modes of action from different chemistry, different groups is a good way to deal with resistance because you come at the pest from different directions. You won't select for a wild type that's resistant to that particular chemistry, or active, I should say, if you use multiple actives. So that's long been held as a good way to deal with resistance, either to battle resistance you already have or to prevent resistance from popping up. And improved performance. I mentioned adjuvants. There are agrochemicals that say, don't use me without a sticker or a spreader or something. And when they ask for it, you need to use it. Most often, an agrochemical company that says, oh, by the way, you're going to need LI 700. You're going to have to mix that in the tank. And you think, well, why didn't you just formulate it so that I dump it all in? Sometimes they can't. The more things you have in a formulated product, the more difficult it is to fit the next thing in. I saw a really neat talk where somebody pulled out a jar of golf balls and then started dumping marbles in and shook it around, and then started dropping in ball bearings and finally sand. It's really tricky to get so many different things to fit in a volume. It was a metaphor, obviously, but the point stands. The more products you try to put into a formulation, the more likely you're going to create a problem or affect shelf stability. And this is what a registrant will tell you as a grower. Well, we would have liked to have formulated it, but we couldn't do it. Quite often it's also, well, we would have liked to have formulated it, but it makes our product too expensive and you're going to buy from our competitor. So we're going to sell for this price and just make you go pick that other one up separately. Yeah, I know it's dirty, but it's true. So why would you avoid tank mixing? And honestly, this is what a lot of our talk's going to be. There are good reasons to avoid doing it: biological or chemical incompatibility. And we're going to talk about that. You could end up with a biological or chemical incompatibility because of synergy or antagonism. We'll talk about those too. And the dirty thing about biological or chemical incompatibility is you may never know you did it. The product could look exactly the way it's supposed to look, a nice emulsifiable concentrate, fully suspended and hydrated. You look in the tank and go, that looks awesome. Or, you look on the crop, the residue looks good, but you have no idea that maybe your product is hotter than it should have been, or that you've inactivated some of the active ingredient and essentially you've just sprayed water, or you've created a situation where the plant is going to respond negatively to what you've done. On the other hand, you may know right away, and this is a big thing that happens with herbicides a lot. You cook the plant you're trying to protect. Sometimes they grow out of it, sometimes they don't. The more obvious incompatibilities are physical. This is when liquids stop being liquid. And when that happens, the really big problem is you mess with your productivity. That could be because, well, you got to stop and shovel the sprayer out. Believe me, I teach a lot about cleaning sprayers, and using a shovel is not a great way to have to clean your sprayer. Also, efficacy. If products don't mix correctly, then you don't end up with droplets that have the right amount of active in them. Or as you're driving along spraying, you could be spraying more active at the beginning of the tank and far less at the end. So you don't get homogeneity. It isn't the same. It isn't uniform. You end up with hit or miss. So that's no good. So let's just drill down a little. I mentioned synergy. Synergy is when you make products hotter, if I can be pedantic about it. You increase the potency. Instead of these two products being so powerful, together they become super powerful. Again, this happens in herbicides a lot, and you end up harming the plants you're trying to protect. So sometimes you can make them hotter by allowing them to be taken up by the plant more readily than the registrant ever intended. Sometimes that can make cells leaky, or they can find different ways in. They can melt through cuticle and get into the plant that way. Sometimes they can get in through the stomata, the little breathing openings on the plant leaves, or sometimes you increase crop retention. That sounds like a good thing. Wouldn't you like your product to be a little more rain fast? You can go a little far with that. And if it stays super hot in one spot in a concentrated form for too long, it goes from being a nice day out in the sun to a sunburn. You can also overwhelm the crop metabolism. Again, this is a bit more of a herbicide thing. Some products work so darn well that it ties up the biochemistry of the plant and it's not available to do other things. Now that's synergy. Then there's antagonism, where synergy makes things hotter, antagonism makes things cooler, takes away their potency. Here's a few examples. If your carrier water, your tank water, if the pH is wrong, it could interfere with how the product is supposed to work. And you should let's get away from that right now. When I talk about tank mixing, It's not just the actives, or I should say the formulated products you put in your tank. It's also the water. Water plays a gigantic role, your carrier, in how products mix. And we're going to get into that. So in this case, let's say the carrier's pH reduces the half-life of a product. A great example is Captan. People use it all the time. Captan should be able to sit in your tank at pH 5 for about 32 hours. It'll stay just as hot. Now, I'm not advocating leaving a full tank of product around at the end of the day to get back at it the next morning. Honestly, I can't think of a worse way to increase residue in a sprayer or have it soak into your lines. I don't like it. Plan your spray as best you can. Obviously, we get rained out, it happens, or blown out, but it's really not the way to go as normal operating procedure. On the other hand, if your carrier water was slightly basic, pH 8, your Captan went from having a half-life of 32 hours to 10 minutes, which means by the time you get halfway down 2 rows, you're spraying water. Some actives can get tied up in antagonism. A great example is spraying certain herbicides with water that has colloids or dirt in it. Roundup, atrazine, metribuzin, those clay-based herbicides will tie up the active in glyphosate, Roundup. So a good example of that is you may have heard never spray Roundup on dusty days, because the dust that's in the air, the droplets will hit it, the Roundup will bind to the dust, and it won't be active for where it needs to land. It happens all the time. But clay-based products can bind up certain actives. Another form of antagonism is changing product retention and uptake. And this is a wild one. This is one nobody thinks of, but it does happen. It almost sounds like synergy, but it isn't. Weed foliage, it can be so effective that one product in the tank can burn the receptors that you want the other product to be taken up by. So let's say you have a systemic product that has to get into the plant and down into the roots to kill the weed. It won't do that if you slam the door shut. One product just burns the foliage and it won't take up the second product. So it may land, but it doesn't get drawn up into the plant the way it's supposed to, and it just grows past it. But physical incompatibility is the fun stuff. For me, it's the stuff where you get to see what's in your tank change shape, and that's kind of cool. Unless it happens to you, then it stinks. Liquids, typically emulsifiable concentrates, they can solidify into toothpaste or gelatinous forms. And this, believe it or not, is a filter, not a candle. And that's what happened here. The emulsifiable concentrates, I think this was partially an agitation issue, but they completely solidified into this gloop. And when that happens, every filter on your sprayer, every nozzle can just get coated and clogged with this stuff. And it's just a nightmare getting it all back out. Dry products are the ones that have the most renown for trouble in air blast sprayers. They fail to suspend. So imagine dropping sand into water. It's going to drop right to the bottom. That's why agitation is so important. Some formulations will not hydrate. That is to say, they will not suspend and stay suspended. They need a little help, and that's agitation. So dry products, if they aren't added correctly, can fail to suspend or hydrate. They can fail to disperse, and just imagine little fireworks. The granulars go in, liquid hits them, and they just sort of explode. And when they do that, they're better able to suspend in the water. But if you coat that firework, if you drop them into an oil before they hit the water, they'll never hydrate. They'll just be coated like a chocolate-covered almond, and they'll fall right to the bottom. That becomes sediment, and that means when you first turn your sprayer on, your pump sucks a huge glog of gloop into it, which pumps just love. You're going to lose suction. You're going to plug your intake filter. It's a nightmare. And if you do manage to churn this gloop through, it will find its home in your screens, in your nozzles. And if you're fortunate enough to pump this tar through the intake screen, through the pump, through the lines, through the filters, and then through the tips, you won't be spraying a uniform solution. You'll be spraying something that has little concentrated chunks of active ingredient in it, hidden in a drop of water. So you can't possibly expect that product to work as it was intended. And that's one of the insidious things where you've created an incompatibility and everything seems to be working, but it's not doing the job it's supposed to do. So let's drill down into some of the physical incompatibilities. Here's suspension issues. Poor suspension can arise from incompatibilities, but also some of your practices. If you let your tank stand without agitation, and I think we've all done this, I said earlier, if you got rained out or blown out, if you leave a tank for extended periods, things will tend to fall to the bottom of the tank. That's a definite way to create a suspension issue. Some of them will resuspend, some won't. If you are being a little stingy with your carrier water, and you know, we could just spend a whole day talking about this, but if you decide, I don't want to do all these refills, maybe I'm just going to go with less carrier water and concentrate the product in the tank. This is often a case when you're using ultra low volume sprayers. It's a constant battle that certain products do not want to be applied in an ultra concentrated way. They need water to suspend, and we're always fighting that balance. But if you do choose to use a really low carrier water, trying to be productive, you may not be able to suspend your product. And this one is really neat, low carrier temperature, obviously something that's more of a big deal in the spring. When your water is super cold, it's not going to dissolve or suspend products the way they're supposed to. So here's an example. These are 2 herbicides. This is a suspension example. And this is one of the live demos we did. We put 2 products in 2 pop bottles. We use Marksman and we use Valtira. These are 2 herbicides that nobody in their right mind would ever mix together, but they make for a good example. And we just let them sit overnight. And if you look a little on the left, you can see at the little nubs on the bottom of the pop bottles that there's a clay-like product at the bottom. And this is where my colleague Mike shook these as hard as he could for about 5 minutes, each of them, in an attempt to resuspend what had fallen to the bottom. And Mike lost about 8 or 10 pounds at the end of that summer. He thought this was the best calisthenic he'd ever done. So on the left is Marksman. After 5 minutes of wicked agitation by Mike, he couldn't get it back into suspension. He eventually could as he got stronger, but it showed how much effort there was involved. Whereas Valtira on the right just turned to chocolate milk in seconds with very little effort. So what's the point of this? If you tank mix certain products and they have different abilities to resuspend, you will eventually turn Valtira into foam by the time you get Marksman to go back into suspension. So this is a form of tank incompatibility you don't think of because you don't plan to have it sit at the bottom of the tank for extended periods. But you need to know how the products behave so that when you have to correct that, you know they're both going to behave the same way. I alluded to water or carrier quality, and the carrier can also be a fertilizer, by the way. We'll mention that. Water quality plays I say important, I would say pivotal role in tank mixing. And it's really important if you've never done this to get a qualified lab test to establish a baseline for your carrier water. Now that, I don't know if I mentioned it in the slide, but a dirty trick is your water in the spring may not be your water at the end of the season when maybe water runs a little low or we don't have snow melting anymore or aquifers start to drop. It can change depending on your water sources. So you may actually have to get a lab test for different points in the season if you know your water changes a lot. But here are the 4 things you want from your lab test. You want to know your pH. You want to know the hardness of the water. You want to know your bicarbonate levels. And you want to know your total dissolved salts or your salinity or your conductivity. There are different ways to put it, but those are the negative ions in the water. Now, if you're spraying with municipal water, it's pretty stable. Like you don't necessarily have to do this, but it's the surface sources. And I did mention this. They will vary depending on rainfall, drought, other factors. So you need to consider that when you test it. Rule of thumb, if you're spraying with water, you want that tank at least half full of water before you add the very first product, and you want the agitation on. So I've heard some people say 3/4 full for water. I guess it just depends on the level of productivity. We've demonstrated, and we've done this math, that faster fill times are one of the best ways to improve your work rate. It's not driving faster. It would knock you out to discover that you're probably spraying 50% of the time that your tractor is running. The other 50% of the time you're traveling from here to there, or you're filling, or you're turning at the ends of the rows, or you're doing something other than actually spraying. So driving a few extra miles an hour, if you're capable of doing that, isn't the way to save time. It's looking at all the other things you're doing during the spray day and trying to find efficiencies there. So some people have said, well, I'm going to get an inductor or a nurse truck or similar and a 3-inch line, and I'm going to fill this thing in 4 minutes. Okay, you could do that, but make sure your tank is half full of water before the first product goes in. Now, fertilizers as a carrier are different again. Fertilizers are a real wild card, kind of like an adjuvant. When you're mixing, and again, this is a field crop thing more than you guys, but if you're using a fertilizer as a carrier, people think just because fertilizer looks like water, that it's water, and it ain't. Fertilizers have lots of salts inside. I'll go back to my little metaphor of a jug full of golf balls. Well, that's water, but a fertilizer is a jug full of golf balls and ball bearings and marbles and sand before you ever add any other product. So there's really not a lot of room in that liquid to soak up and to dissolve another product, which is why we need more of it. So you absolutely have to have a 3/4 full tank if fertilizer is your carrier. The point of this is you do need that liquid to dissolve and disperse and hydrate your products. Here's a good example. It's funny in extension how you find pieces of junk and garbage, and you buy things that if anyone ever looked at what I bought through the year, they'd have no idea what I do for a living. Here I bought a frame from Walmart and a red t-shirt, and Mike and I mixed Sencor, which is a granular, at 220 grams per acre, or for 500 gallons per hectare. And we mixed it at 3 different concentrations. So we did 20 US gallons an acre, 10 US gallons an acre, and 5 US gallons an acre. All of this to say, we tried putting a dry product in a lot of carrier or a little carrier. And then we poured the result solution after we thought it was as dissolved as it was going to get through a red t-shirt. And we just cut the little swath out and put it on the frame. And look what you get. At 20 gallons per acre, where there was enough water to dissolve the carrier, even though we agitated it, we still filtered out some chunks. And you may look at that and think, big deal. And there's always a few little chunks. Okay, but that's product that didn't get dissolved, which means what's coming out of your sprayer isn't at the level of active that it should. It's not as heterogeneous. It's not uniform. Once we get to 10 gallons an acre, we just didn't have enough water to dissolve it. So this would have been sitting at the bottom of the tank, or it would have gotten caught in filters. And at 5 gallons an acre, wow. I mean, that was trouble. You don't want to see that at all. So the more carrier, the better. Temperature was neat too. We did a very similar test. We mixed exactly the same amount of product of Sencor, but we did it at 15 degrees Celsius and 5 degrees Celsius. I'm sorry for the metric. I probably should have converted that. Hopefully you're all doing that in your heads, because I never understood Fahrenheit. I can get my head around acres, never got Fahrenheit. Just know that 0 degrees Celsius is freezing. So 5 degrees Celsius is pretty darn cold, maybe even aggressively so. But look at the difference. And this goes back to that old analogy that if you put sugar in hot water, it dissolves. If you put sugar in cold water, not so much. We did it a different way. We used coffee filters. That's what you can see at the top, kind of cut open and laid flat. And there's our, Celsius thermometers at the bottom. At about 20 degrees Celsius, a nice warm day, WeatherMax completely dissolved. In the middle, WeatherMax at just above 0, not so much. And then one of the registrants said, well, of course not. WeatherMax needs Agril 90, a surfactant. That needs to go in there. You silly buggers, you should have used it. We said, okay. So we did. And there it is on the right. Better, but nothing I would be happy to see stuck in my filters. Water or carrier temperature matters. Now, physical incompatibility and poor sprayer sanitation has a price. It's not just that you're spraying gloop, but boy, over time, those residues that form, even if they do get through your sprayer, they cake on. They leave little bits of themselves behind. And when that happens, they have a tendency to break loose when you least expect it. This is a problem with herbicide applications we get these calls all the time. What did I do to my beans? It looks like I've got a herbicide on there. I've got white leaves, but I haven't sprayed that out of this sprayer for 2 months. Like, it was 8 tank loads ago. Where did this come from? And where it came from is that one of the new products they put in the tank actually had a synergy or an incompatibility with what was in there before, knocked it loose and took it with it. So any of the residues from other bad tank mixes that weren't cleaned out properly, or just bad cleaning sanitation processes in general, it took another product to scrub it out. There's a saying that glyphosate is one of the best tank cleaners out there. It tends to loosen up everything. So, when we talk about incompatibilities, it may not even be a problem that's immediate. It may be something that's ticking like a time bomb waiting for you down the road. And in vineyards and in orchards, this could be the same problem as oils or fertilizers with certain fungicides. Things break loose when you don't want them. Or if you're moving back and forth between crops where one product is registered for one and that same product is not registered for the other crop, you could end up with residues that aren't supposed to be on that fruit. And all it takes is a white test to reject that fruit. So you don't want it. And I think I said all that. Yeah. I like this. I always include it, whether it's a specialty crop talk or a field crop, but this is neat. This is the grower that shared this with me swore up and down he didn't do it. And I always smiled politely. Everybody seems to ask questions for other people or happen to take photos of other people's fields. So I just smile. But look at the burn on this. This is classic residue burn from a field sprayer. You can see all 7 sections. And typically when you start, the residue always ends up on the outer sections. That's where it's pushed and has the lowest pressure. It gets caught in the boom ends. And you can even see where they, right where the numbers are, where they stopped and charged the boom. You can see the white line there before they got rolling. And as the sprayer drives, the liquid feeds into the center of each section, pushes the product to the outer ends. And that's where you get that kind of shark bite pattern. So I think a reason a lot of our field crop brethren may be a little more diligent about sprayer sanitation is they can't get away with any product getting left over. For one thing, they're teased mercilessly by their neighbors. For another, this is the kind of crop damage that a herbicide application can cause if there's residue or with poor sanitation. With fungicides and insecticides, we don't see that damage. Believe you me, we're doing it. We just don't see it. Foaming is another form of physical incompatibility in a tank mix, and it's not often considered because what do? Well, we just drop a little anti-foam in there. We do it without even thinking about it. But foaming can be from physical incompatibility as well as over-agitation, and that causes overflows, which is a waste product, and also point source contamination. Nobody was ever thinking about 100% full strength product being dropped in one physical spot when they looked at environmental safety or toxicity. Believe me, they were looking at drift. They were looking at what happens if this gets into a water or a well, but they weren't thinking what happens if we dump a ton of this in one spot over and over. So it's not good stuff. Foam also can break pump suction. For those using a pump where that can happen, if it sucks down a bunch of air, it's all over. You're going to have to prime it again. Your application becomes non-uniform. Maybe the active tends to want to be in the foam, or maybe it's at the bottom underneath the foam. I did this. I'm going to fess up. We were filling a field sprayer with, of all things, dicamba. It was for a volatility study that I was part of, and we used anti-foamer. We did everything we were supposed to do, but what we didn't do was back the agitation off as the sprayer was filling. So we had full bore killer agitation with only half a tank full, and it frothed up like a milkshake and foamed over. And boy, what a mess. It happens. So a great grower that I follow on Twitter, Wimira, W Crop W, he had a really neat way to deal with it. I guess overflows happen all the time in Australia. I don't know, but they came up with this neat way to put a bucket underneath with a micromatic fitting. So when the overflow happened, the bucket catches it, and then they used the fitting to pump it right back into the tank. No fuss, no muss. Clever. Then there's phase separation. That's another form of physical incompatibility, and it can lead to a non-uniform separation. And the best analogy is salad dressing, and that's what we have on the right. Shook it up, let it sit, and it's separated into layers, oil and water. And if you look down into the top of your tank, what are you going to see? You're going to see the herbs on top of the salad dressing. I've never seen a transparent tank, and most of us that have a tank level hose on the side, those go opaque. You can't see through those. Even the sprayers, the fiberglass ones that have the window, you can't see through that either. Point is, you don't look at your tank side on. You only look top down through the open lid. So you never know that it's separated. And then what happens? The sump is usually at the bottom of the tank, or it should be. So it's going to suck off that bottom layer, spray it out, then suck off the middle layer, spray that out, and then the top, agitation notwithstanding. The point is, instead of spraying evenly behind you for a tank, it's kind of like spraying 3 different super concentrated tankfuls, and only a third of your vineyard gets covered. So not good. So how do we avoid all these problems? I mean, I'm just laying out doom and gloom. I don't like to do that unless I have a solution, no pun intended. So let's talk about some of the overriding principles here. First, the more things you put in your tank, the more potential for incompatibility. I talk to people that say, I never put more than 1 or 2 or 3 things in. I've talked to guys that have put 8 different things in their tank. Second, do not decide on a tank mix while you're standing there at the loading station. You decide on this stuff before the season starts when you're placing your orders. Having a scout or somebody with IPM knowledge or a very influential adjuvant salesperson tell you 2 days before, yeah, I saw this out there. Maybe you want to chuck this in the tank. Or I heard that this does a good job. Or the wind might pick up. Why don't you throw this in? It's only $1 an acre or something. Yeah, why not? What could it hurt? And you end up turning your inductor bowl or your sprayer into a kind of a black art, weird chemistry set. That's no good. Contact the manufacturer of the product somehow. That could be their website. That could be the sales rep. Maybe it's the crop advisor that you pay or someone in ag extension that you trust to help you track down information about incompatibilities. The point is, demonstrate due diligence. If you ever find yourself in a situation where you've made jello or you've damaged a crop, you want to be able to figure out, well, it's less about who to blame, I suppose, but more to track down what caused the trouble so you never do it again. And if you do cause a lot of damage, maybe it is who to blame. Did the agrochemical company not put that information on the label when they should have? Did the sales rep make a boo-boo? Did you make a boo-boo? And then there's the pesticide label. Funny, I put that at the bottom. Most people mention that at the first because there's the pesticide label, the most delightful 48-page, 4-point font article you've never read, strapped to the outside of a box or a jug. I'm wearing glasses as I talk to you right now because there's no way I would see that any clearer than what you're seeing on your screen right now, a blurry, wavy bunch of dots. They stink. The pesticide labels are laid out in a non-intuitive way. They contradict themselves on occasion. They're silent on important points on occasion. They're just a bugger to navigate. There's a better way to do it. Now, in Canada, we have the PMRA, the Pest Management Regulatory Agency, and that's our federal body under Health Canada that uses data to register products and has all their labels online. Now, admittedly, they're in PDF, and if you've ever tried to search a PDF or look on your smartphone, it's awful, but I suppose it's better than nothing. If you have your pesticide labels in PDF format, you can probably get that through the agrochemical company themselves, or maybe there's a trusted website you know. They're not so bad to search if you use your keyboard. Control F means find. If you hit Control F, you can search for the following keywords: do not mix, mix, hours, agitation, and fertilizers. And we chose these because these are the words that always bring up the big problems. If you type do not into a search engine on a pesticide label, you're done for the day. Do not appears about 8 bazillion times on a label. but do not mix is a bit more pointed, and it'll quickly alert you to tank mixes that you need to not do. Mix may also be a way to tell you which products you need to add, or again, which you really shouldn't. Hours, that's an interesting one. How long products will stay active when mixed together. Agitation, sometimes they want you to agitate the heck out of something, and sometimes they don't. And fertilizers, there's nothing but caveats. When you throw fertilizers into the tank, either as a carrier or as a tank mix partner, they do tend to cause a lot of trouble. This is a good example. And just before I sat down to give you this talk, I got an email, because this is going on right now here in Canada, and I suspect in the US as well. This is an interesting story. When we figured out that acid rain was bad and stopped a lot of North American acid rain, we inadvertently removed a source of sulfur for corn. Maybe you knew this. So it's funny, we solved one problem and kind of messed up in another. I guess it's not really messing up, but the point is corn started to have sulfur deficiencies. So what a lot of growers were doing is mixing in ATS, which is a sulfur, with UAN, which is a nitrogen fertilizer. It's one of the first passes through a cornfield. So they figured, why not put my sulfur and nitrogen on at the same time? The timing's right and it's great. But if you mix ATS and UAN together, you get what's in the jar on the left, which has the consistency of chewing gum. Not that I would ever chew it. And unfortunately, these products were coming co-packed from the registrant, not pre-mixed, but two packages together. And the growers were chucking them in. So we wanted to see how maybe we could suspend these better. This is a 1-to-3 ratio, ATS, the sulfate, and UAN, the fertilizer, and we got gloop. In the second one, the one in the middle, we thought, well, maybe we need to use less sulfur to nitrogen. So we cut down 1-to-8, and it looks like a nice, creamy, emulsified, suspended product. It looks milky, it looks better. Unfortunately, guys still needed more sulfur, so that wasn't a solution. Turns out the solution was the mixing order. Instead of adding UAN to ATS, if we started with UAN, then added a herbicide, and then added ATS, which is a pretty typical tank mix, it went into suspension. So while nobody in a vineyard gives a damn about this particular product mix, it is a great way to demonstrate how mixing order makes a big impact on tank mix compatibility. So let's hit that for a second. Assuming you have your carrier tested and you know the qualities of the carrier and you've corrected it if necessary, and sometimes you need to, you have to decide on what order you put your products in the tank. And I'm sure a lot of you, I hope a lot of you, have encountered the acronym WALES: wettable powders, agitate, liquid flowables, emulsifiable concentrates, surfactants, WALES. That's supposed to be the die-hard, never-fail order that you add products. But even though formulation chemists, and I've talked to a lot of them, not all of them, obviously, expect this to work, say, 95% of the time, other acronyms come up. There's one from BASF called WHAM legs, rolls off the tongue. There's one called Apple, which I'm suspicious of because it's just such a cool acronym. I have to wonder if they forced it just to make the acronym. So I wondered, is WALES broken? Like, why do we need different adjuvants? Sorry, orders. And I think I'm gonna stick here just for a second longer. Here's what I found out. If you picture WALES as each of them being a category, so W is wettable powders. Well, there are lots of different categories of wettable powders. Then there's agitate and liquid flowables. Liquid flowables actually represents a subset of different formulated chemistries. The reason you get different acronyms is some groups feel that it's important to elevate one of these products from the second tier to the first. So if I have two kinds of wettable powders, someone will say, you know, I think it's important to say which wettable powder goes first before another wettable powder. So suddenly you get a different letter in there. The point is, WALES isn't broken. This is still the order you do things and it works. It's just under special circumstances, some of the products within each category need to go before others. And don't freak out. That's almost always on the label. It's one of the things you can count on, but we'll get there. So water-soluble packages are much more common in our world in specialty crops, and they're a pain in the butt. I've never managed to get somebody to sign their name to the best way to use a water-soluble package. And that's because they're considered a closed transfer system. You can tell I work for the government. A closed transfer system means you never open a jug, you never open anything. It just goes from the format that you bought it in into your sprayer. It could be pumped in, it could be locked into something like a goat throat, if you've ever seen that. Point is, you never come in contact as an operator or as a loader with the product. And water-soluble packages are made that way. You're never supposed to see the pesticide. You just drop the tank in or drop the pack in. But if you throw a water-soluble package into a basket and have the fill water hit it, you get a puff of powder that's not good. It's not good for you. It's not good for the environment. It's not good for anybody. So you've got to really be careful with that. You can't just drop it into the sprayer half full, because they tend to get sucked into the pump, and that'll mess up a filter or just cause trouble for the pump. So what do some people do? They cut the bags, and boy, that sort of defeats the purpose. Personally, my favorite approach is a slurry. And I've seen some really neat tools out there, just cement stirrers or paint stirrers on a drill. You put the water-soluble bag in warmer water in a bucket or a pail, and you dissolve it there in a slurry, and then you add that to the tank. Did you just defeat the reason of having a water-soluble package? I'm afraid so, but you kind of chose the lesser of several evils. Wettable powders is the next one in line. Water dispersible granulars, and then you agitate. You should have had it on the whole time. But this is interesting. This is PACE. These products, water-soluble packages, wettable powders, and dispersible granules, take a longer time than you would expect to hydrate, that is for liquid to soak into them, and to disperse, that is the firework for them to explode kind of into the water and spread out and disperse. Longer than you think. Then the liquid flowables, and here's a whole pile of them, and I've included them in order. So I mentioned to you that under the liquid flowables, there's actually a sub-order, and this is it. Suspension concentrates, susceptible emulsions, capsule suspensions, then dispersible concentrates, and then the emulsions in water. And if you think I know what these are, then I have fooled you beautifully. I don't. I just know the order because I have chemists that I trust that have told me this is the order. And then, of course, the emulsifiable concentrates, and then certain solutions. Note that liquid fertilizers and micronutrients, if they're not already pre-mixed, they go last. There are always exceptions. I should say, if the label says specifically, put this now, then do it. But without guidance, this is the order that you follow. It's this, the adjuvants get a little goofy. Compatibility agents and antifoamers, they should go before the pesticide. So the idea there is, remember our Captan example. If the water is pH 8 and you drop in Captan, you've just started the clock ticking. So you want the water preconditioned at the right pH, etc., ready to accept the pesticide. Antifoamer should go in before the foam starts. But adjuvants should also be added based on how they're formulated. If an adjuvant is an emulsifiable concentrate, then it goes in with the emulsifiable concentrates. Again, unless the labels tell you otherwise, this is what you can do. Keeping records. Now that hopefully I've scared you a little bit, maybe, about all the things that can go wrong, it's really important to write down what you did. Oh boy. It's really important to write down what you did and when you did it, because if it works, you want a record of it so you can do it again. And if it fails, you want to know what you did so you never do it again. I always liken it to cooking for your family. If a recipe works, I'm going to roll with that again. If my kids turn their nose up, probably not going to happen a second time. Pace and pre-mixing, and we're doing well, by the way. We're getting near the end, my patient people. Pace and pre-mixing, they're important considerations. Some products, particularly the dry products, can take as long as 5 minutes to be truly hydrated and dispersed. And that's particularly important when your water's cold. You saw that earlier. So, the rule of thumb is if you think it's dissolved, even if it looks dissolved, probably isn't. And I mentioned prehydration or creating slurries. It's a good way to deal with dry products as long as you treat the products with respect and you're wearing the right PPE. I did remind you, beware cutting solubags. If you're going to do a slurry with a solubag, place it intact, start the drill slow or whatever you're using for mixing, and then speed it up. And some larger operations, they have nurse trucks where they'll hot load. They'll actually pre-mix the entire tank load, and when the sprayer pulls up, they load it up right there and then. This is what aerial applicators do all the time. So what if you've done your diligence? You've got, we'll keep it simple, 2 labels. One says, don't mix me with X. And the other says, please mix me with Y. They're in direct contradiction. It happens. It happens all the time. Then there are labels that are completely silent. So what do you do if the labels don't make sense or they're just not telling you what you need to know? Nobody seems to know. You've been to the coffee shop. None of your fellow growers have ever tried it before. The salesperson who wants you to try an adjuvant said, yeah, throw it in. It's going to be great. And then you say, could you write down that you told me to throw it in inside your name? And they go, well, I'm not willing to sign my name, but I heard it's okay. That's a big warning, by the way. You're going to need to test it for yourself. And this is where we do a jar test. Jar tests, if you haven't done it, is kind of like filling your sprayer in miniature. It's just a trial run. So everything in the little jar is in the exact same ratio as would be your full tank. So to do this correctly, you're going to need a disposable syringe. You're going to need a cheap digital scale. You follow all the same rules as you would if you were filling your sprayer. Now, I admit, bringing some of these products down in ratio, that's tough. Like, how do you take 4 kilograms of product and bring it down to half a teaspoon? You do have to do some thought. If you're not interested in that, there are kits out there that have already done it for you. I like this one. There are others. This is by Precision Laboratories. And as I say, I'm not boosting any particular product, but I've used this and I liked it. They've already kind of worked out for each different formulation how much you need. And this kit comes with the gloves and the little disposable micropipettes. And if you cut the back off, they become scoopulous, which is a chemistry word for just a spoon, I suppose. And each of these little vials have a line drawn around them that represents how many gallons. It's all kind of been pre-done. And what's neat about this is you instantly see, well, not instantly, but you see pretty quickly whether 2 products are going to foam or make a residue or fall out of suspension or become a gel. In fact, I like to take it a bit further. Once you've done your jar test, put it away. Put it in the chemical shed. Put it somewhere where obviously it's not going to be, tampered with, and see what happens after, say, overnight. Why not use the jar test the same way you would perhaps let your tank sit? If it all falls out of suspension, give it a shake. Can you get it back into agitation, or can you agitate it back into suspension? Does it leave a film around the inside of the plastic that would tell you that maybe this stuff's going to be hard to clean out later? And I should note, the jar test will only tell you about physical incompatibilities. You have no way to know if you have a chemical or biological incompatibility, because how do you know if the product is inactivated or super hot? You'd have to go with a squirt bottle and spray a plant. To date, I've never met anyone that's ever admitted to me that they've done that, by the way. That's just almost too much to ask of anybody. It should be something the agrochemical companies do. But why would they do that if perhaps you're mixing with a competitor's product? Plus, the permutations are through the roof. There are so many variables, you could never expect to capture them all. So not good news there, but at least for a physical incompatibility issue, this works really, really well. So if you make a mess, and it happens, and we had growers come to us after our demonstrations and say, I've been mixing these products for 15 years. I have never had a problem. And then one day I did. And it turns out, and this happened a few times, it turns out the products were formulated differently. It's very rarely the active ingredient that causes an incompatibility, by the way. It's all the other stuff inside there, the stabilizers, the pH adjusters, the deposition modifiers, the stuff that makes it shelf stable, the things that allow it to emulsify and spread. For every one active in a jar or a jug, there's probably 15, 20 other things you're not even aware of. So when they make small changes to that and then, not realize there's an incompatibility, you could reap that horrible reward. So if you do make a mess, what do? Everybody's instinct, fill it with hot water and detergent and try to break it up, pump it through. Please don't do that. That's not your first go-to move. Your first go-to move should be to perform what I'm calling, or what Mike and I call, a reverse jar test. Scoop some of it out. I mean, wear your gloves, be safe, and try to break it down in the jar. The same way that you would have done a jar test to begin with. Add your detergents, shake it up, try to heat it up, see what happens if you add more water to it. Because at least that way, you solve or try to solve the problem in a jar rather than adding more volume to an existing nightmare. And then you've got more residue to deal with and more product that has to be dealt with. We're right at the end. Thank you. Avoiding tank mixing errors. This is what I think gave me the confidence to start down this road. I was invited by Fred Whitford at Purdue, and Purdue Extension, they just make gorgeous knowledge transfer content. Their booklets are fantastic. And not just because I help edit and write some of them, but Fred's a machine. He puts out more content than most of us do in a career, and he does that in a year. But I got part of this particular project, and I got to work with a lot of chemists. I learned a lot about tank mixing. Since this was written, I got to confess, there are a few little parts of it I don't agree with anymore, but it's still a fantastic resource. And I'd say it's like 90% there, maybe 95. You may not even encounter the problems that I don't quite agree with it anymore on some of those points. Whales, for example, not being broken seems to be one of them. But I highly recommend you download it. I shared a few links with the hosts for an article on jar tests off Sprayers 101, which I'll talk about in a moment, and another on physical and chemical incompatibilities. And the link for this is right there on the website. Now, shameless plug. 5 or 6 years ago, I wrote a book, and it was on air blast spraying. And I wrote it for Southern Ontario, for Ontario, because there was nothing out there. And I was proud of it. Of course, I was proud of it. But I found out a few years later that it was going a lot further than Ontario. It ended up in Australia. It ended up in Europe. And it was never written for those environments. Advice I would give somebody in Wisconsin on how to spray, I would never give somebody in California. Just the temperatures and the heat alone make massive differences. Certainly the equipment and the cropping systems, and they're just a whole other world. So during lockdown, I wrestled with a couple of colleagues and managed to lie, blackmail, and cheat my way into getting them to co-author a second edition, one that was intended to be more worldly, one that would expose international best practices to anybody that read it. And we worked really hard to hide the physics, or at least to keep it conversational so it wasn't quite so boring or intimidating. And I'm very proud of this, and I hope it's the last book I ever write, because it was a pain. But this is available now. It's free. You can get it off Sprayers 101 as a free digital download. But if you prefer paper, as I do, you can get it in hardcover or soft cover at cost through print-on-demand publishing. And it's everything you never wanted to know about air blast spraying. And you can find that on a website that I run with a colleague out of Saskatoon called Sprayers 101. And on that website, there are hundreds of articles on spraying, all different cropping systems and equipment, everything from drift and personal protection to some more lighthearted stuff. We've got a dozen exploding sprayer myths videos that we like to think are funny. We've got a comic book called Micron Woman that teaches you how droplets behave or misbehave. We even have, believe it or not, songs, like anything to keep the job fun. But there is a lot of solid content in there written by us and written by a lot of contributing authors. It's, again, entirely free with a very easy to operate search engine. It should be valuable to anyone that's interested in learning more. So I'll stop there and I'll stop sharing my screen.
Well, that was great. Thank you. You managed to go right up to 2 o'clock.
Yeah, you said I had the time, so I let it roll.
All right. Yeah, so people might kind of start logging off here, but we do have some questions. So if you don't mind hanging
I
out.
don't
Maybe
mind. I'm sorry it went that long, but you shouldn't have told me I had the time.
No, that it was all really good content. It's great. So Thomas's question, is there a method to keep a product from foaming when mixing?
There are two. One, if you have a sprayer, if you have a hydraulic return sprayer or a hydraulic agitation system, you can install a valve, like a butterfly valve or a quarter turn, actually a quarter turn, to actually cut back on the agitation early in the filling and add your products, and then slowly ramp up that agitation as you're getting near the end of the tank. That's one way to stop it from introducing or whipping up too much air into the whipped cream. Alternately, antifoamer is great stuff, and you throw it in before you even start. If you know you have products that are prone to foaming, it's the equivalent of dropping a bit of dish detergent on oily water. It just breaks down. You just watch that oil ring separate on top of the water. So backing off your agitation and using an antifoamer are great ways to deal with foam.
Okay, great. Another question is, can I tank mix a 20-20-20 fertilizer with a fungicide?
I have no idea. It depends on your fertilizer. It depends on your fungicide. It depends on your temperature, all the things I talked about. But I'll roll this back to you. Hopefully I've given you the power or the knowledge to test this yourself. Get yourself a jar. Do the mix. First, look for a physical incompatibility. Give it a little time. Let it sit overnight. See if it forms residue. See if it falls out of suspension and how hard it is to get resuspended. And then you could be the very first person I've ever met to put this in a spray bottle and actually spray. Pick a sacrificial plant, give it a shot, watch it like a hawk. Now, unfortunately, what that means is you won't be able to do it this year. You'll be able to do the test this year, and then you watch it very closely, and that gives you the go-ahead to do it next year. But if you can't find an agrochemical rep who sells these products to sign off on that, there's probably a reason for it. So ask the people that made the products, do they know of any reason why you shouldn't do this? Ask the person that told you to try this. And if no one that you know has ever tried it, I don't think you want to be the test monkey. Do the jar test, consider spraying a little test area with a squirt bottle and see for yourself. There's no way I can answer that question except to say be cautious. I'm sorry about that.
All right, thanks. Maybe something that I would add to that. I mean, if you're talking about a 20-20-20 as a foliar fertilizer, I think the applications of that in grapes are really limited. I mean, we usually we recommend putting on your macros as a soil application, not a foliar application. So just always have a really good reason and justification for why you're spraying something on the leaves of a plant. So if somebody asks you, why are you spraying that? You have a really solid answer right away.
See, I was thinking instantly about the tank mix and less about whether it was even a good idea.
Oh, I know.
I was too focused.
Yeah, that's all right. Okay, so I don't see any other questions in here right now. I'll check the chat one more time.
There's one in the chat.
Is there?
Just came up.
Okay. Oh, what is the best water temperature to use for mixing across all products?
Wow, wouldn't it be nice if there was one? The warmer, the better. It's not so much about how warm it needs to be, but how cold it shouldn't be. The colder it is, the longer it takes for products to suspend. So if you have water that's really cool and a comfortable, relaxing drink, then it's probably too cold for your product. I've known guys that have used holding tanks painted black to keep algae down. If you've ever had a problem before, if you've noticed that products won't suspend, it's probably too cold. But I'm afraid there's no actual 14.3 degrees Fahrenheit kind of response to that. Just it's more of a subjective thing. The warmer it is, the more likely you're going to have a good tank mix. The colder it is, the longer you're going to have to wait between additions, and the more potential for incompatibilities from rushing each tank mix partner.
Mm-hmm, mm-hmm. Okay. And since I don't see another question, I'll just make a comment that I get questions sometimes from growers about sulfur and cleaning sulfur out of a tank, expressing frustration with how difficult that is. Do you have any tips on that?
All I can say is it's a question that I get all the time too, and I don't have a good answer for that. It's a complete pain in the butt. It sticks to everything. It's like blowing cactan off the outside. I can tell you, the sooner you can clean your sprayer, and that's inside and out, the less trouble you'll have with it. Once it dries out and sticks, then it gets really, really bad. So as soon as you can get back and deal with it, the better. The longer you let it sit, the harder it's going to be.
Okay. And then another example, I had a grower a few weeks ago spray what I think is a pretty hot mix. He tank mixed 4 herbicides together and applied that because he was struggling with some really stubborn weeds. Can you comment on that? I mean, if he's following label rates for all of the products, should he still be concerned about combining that many modes of action at once?
We have a researcher here in Southern Ontario, Dr. Peter Sikkema, and he's fantastic. He seems to have mixed every possible active from every formulated product known to man. And what they found is when you're, and this isn't always the case, but if there's a certain product that you don't want to put on because there's resistance, there always seems to be a cocktail of 3 or 4 other actives that are capable of controlling that weed. And then the reason it's not done in broadacre applications is because it's so bloody expensive to buy so many different actives. So it's not that it can't be done, it's that from a productivity and an expense standpoint, most people aren't willing to do it. So the lookouts on mixing multiple herbicides at full rate, and that surprises me. Most people will cut back on the rates because they have so many modes of action, assuming that they will kind of attack it from different directions, if I can put it that way. You still have to be very careful of incompatibilities. Some of these products do not want to play nice because of the formulations. Adding multiple tank mix products for herbicide applications can control resistance, but don't just do it on your own. There's lots of information out there about stubborn weeds and resistant weeds and tested products at certain rates that'll help you. So turn to University Extension, wherever you can find it, and ask before you try something on your own.
Okay, thank you. All right, last call for any more questions. I'm going to wait 10 seconds in case anyone is in the middle of typing a question. I was on a conference call type webinar the other day where they were only waiting about 1.5 seconds after they said, "Does anyone have any questions?" So
I've heard. I'm counting
enough.
to 6. I'm counting to 6. 6 is a weird number, but that's it.
The silence is hard, but that's why people are typing anyways.
It's always silent in my kitchen. We're good.
All right. I'm still not seeing anything come in. So thank you for joining us. I think this was really valuable and interesting. Thanks for trying to make these topics captivating to listen to. We always appreciate that. And so again, this is being recorded. And so I will send out the recording to everyone who registered in the next few days. And I'm actually taking the rest of this week off. So it might be later than usual, but we'll get it to you. And other than that, everybody just have a good week and a good beginning to the growing season. Thank you again, Jason, for coming and being our speaker today.
Thanks for having me.
All right. Bye.
Bye.